So the first thing we want to do as we introduce units is talk about sort of four basic quantities that we need to make sure that we understand how they relate to each other, but also how they're different from each other. So to start with, let's talk about what a physical quantity is. Well, a physical quantity is literally just the label we give to something that physically we're going to measure or keep track of. And so as an example, let's just take distance, right? Well, every physical quantity has a dimension. Now, often the physical quantity and the dimensions are referred to by the same name, but in the particular example of distance, we might say that the physical quantity distance has dimensions of length. Okay, so this again is starting to tell us a little bit more about what that physical quantity is. So what are its dimensions? Now, when I report a length, I can report a length using a wide array of different units. So I could choose to report a length using inches, feet, yard, miles. I could use millimeters, centimeters, meters, kilometers, right? So, and this is just an incredibly small subset of all the possible units I could use to describe a particular length, right? Depending on how long or short that length actually is, each of these units might be better suited. If I have a really, really short length, I might want to use something like an angstrom, which is an incredibly small distance. If I've got really big, sort of astronomical sized lengths, well, I might want to use something like a light year or a parsec. Right? So again, we tend to pick the unit that's appropriate, or at least on the scale of the length that we're trying to describe. Now you'll notice that I've sort of clustered these units together, and that's because they belong to different systems of units. So the set on the left here, inch, foot, yard, mile, those are imperial units, US customary units, often called British units, right? These are sort of the ones that we often use sort of casually in kind of everyday life here in the US. On the other side, this other set, millimeter, centimeter, meter, kilometer, those are all metric units. And again, the metric system is the one that tends to be far more commonly used in scientific circles. So one of the things that obviously we'll have to do is we'll have to be able to go back and forth between not just units, right? So convert from millimeters to meters, but we'll also need to go back and forth between systems of units. So going from an inch to a meter, right? So we'll need to be able to convert between not just units, but even systems of units. Now within the metric system, there are still a couple of systems of units that tend to be used. So within chemistry, you possibly used units within a chemistry class that were known as CGS units, where you would have been building lengths out of centimeters, your masses you would have measured in grams, time you would have measured in seconds. That's what the C, the G, and the S stand for. And again, that's appropriate because lots of things that chemists deal with, their lengths are on the order of centimeters, their mass are on the order of grams. So using CGS units makes sense. It's just sort of the natural unit system there. In physics, we're going to tend to use the MKS system. So we're going to talk about lengths in meters, we're going to measure mass in kilograms, time again we're going to measure in seconds. This goes by the name of the SI system. So it's from the Standard International system for a metric system of units, and that's going to be the system that we tend to focus on within this class. So you may be given information that's not in SI units, and part of what we're going to do is make sure that we convert things into SI units, so when we plug those values in, we end up with SI units. So let's look at a couple more examples. So again, quantity and dimension for lots of things. So our previous example, we could talk about distance and its dimensions of length. For a lot of things, the quantity and the dimension are really sort of the same thing, right? So when you talk about the physical quantity of mass, it has dimensions of mass. The physical quantity force has dimensions of force. The physical quantity of energy has dimensions of energy. So it may very well be that the physical quantity and its dimensions, those two things are used interchangeably. But obviously, we have choices in terms of both the unit system and the units. So here we've got a set of physical quantities, in this case mass, force, and energy. I can now think about, well, which system of units do I want to report the mass or the force or the energy in? And again, you'll notice up here there are two metric systems, right? So the SI system is a metric system, the CGS system is a metric system, and I've also gone ahead and listed out two British systems, right? So two of the imperial systems. So there's the pound mass system, and there's also the pound force system. And the difference between these two systems is the way they choose to treat pound as a unit. And so then there's all the particular units within those systems. And so within the SI system, right, mass, we're gonna use units of kilograms. Force has units of newtons, and energy is going to have units of joules. In the CGS system, that's a different set of units. So again, mass is now going to be in grams, force will be reported in dynes, energy is going to be reported in ergs, right? So each of these systems have their own unit that corresponds to a particular dimension. Again, in the two English units, or the two English unit systems, notice that in the pound mass system, I'm using pound as the unit for mass. In the pound force system, I'm using the pound as the unit for force. So in the pound mass system, pound is my mass, and the poundall is the unit of force, and then energy is given in units of foot-poundalls. In the pound force system, I'm going to use pound for force, which means I need a different unit for mass. In that case, we use the unit of slugs. So mass is given in slugs, force is given in pounds, and then energy is given in foot-pounds. So just understanding the difference between the dimensions of a physical quantity, the unit system that you're choosing to use, and then the particular unit that you're using to report is critically important to minimize mistakes in terms of dealing with units. So since we're going to focus in the metric system, it's really important for us to know all the metric prefixes. So the nice thing about the metric system is that it's a power of 10 system. And typically, most of the units, most of these prefixes that we use are basically increasing things by 1,000. So you'll notice that in going from, say, mega to giga, you've gone from 10 to the 6th to 10 to the 9th. Well, that means mega is another way of saying a million, giga is another way of saying a billion, and the difference between a million and a billion is there's 1,000 times more in a billion than there is in a million. So that's why the 3 becomes 6, becomes 9, becomes 12, or the minus 3 becomes minus 6, minus 9, minus 12 in terms of looking at these units. We tend to focus on sort of differences of 1,000 in going from one prefix to another. Obviously, when we're around 1, there are a couple additional ones, centi being the one that we probably know best, right? That's 1/100th rather than 1/1000th or anything like that. Again, if you look at this table, there's sort of a dividing line here. And it's easiest to see what's going on if you look in that power column. Because again, obviously all the units that are larger than 1, they have a power 10 to a positive power, right? So 10 to the positive 3 is 1,000. That's kilo. 10 to the negative 3, that's 1/1000th. That means you've become much smaller, right? You're 1,000 times smaller. That's milli, right? So a milligram is 1,000 times smaller than a gram. A kilogram is 1,000 times bigger than a gram. So just understanding that whether you got a plus sign or a minus sign in your power of 10 is telling you whether you have a unit that's getting you bigger or a unit that's getting you smaller. And so we'll want to know all these abbreviations. Again, you may run across other abbreviations, right? So like 10 to the minus 15 happens to be femto. And so you might run across a small f in certain contexts, particularly if you're dealing with sort of nuclear size stuff where things are on a very, very tiny length scale. In terms of thinking about bytes, right? In terms of computers, so gigabytes, terabytes, you may go to even larger a larger prefix in terms of computational power. But as an example, right? So the way that I want to use this table is, let's say I have something that says 1 p.m. Well, the P tells me I've got a pico for the prefix, and the M says I've got a meter. So this is 1 picometer. And the number 1 is going to stay the same, right? So I've got that 1 stays as a 1. The meter stays as a meter. And then basically what I'm doing is I'm converting the P for pico into times 10 to the minus 12. So basically what you're going to do is you're going to say, well, this letter just gets replaced by times for my scientific notation, and then whatever the power is out of my table that corresponds to P. So 1 picometer happens to be 1 times 10 to the minus 12 meters. As a second example, right, 4.2 megawatts. So the big M tells me I've got mega. Mega is 10 to the 6th in terms of the power. So again, the 4.2, the number out front stays the same. The watts, the unit in back, stays the same. And all I'm doing is I'm replacing the M for mega with the times and then the right power, which in this case is 10 to the 6th. So 4.2 megawatts is another way of saying 4.2 times 10 to the 6th watts.